Hello everyone. Today we are going to learn about a topic of class 12, that is inferential statistics. So before coming to the inferential statistics, let's see what statistics is. We have seen in our previous classes that statistics is a branch of mathematics in which we deal with the collection of data, organizing the data, representation of the data, analysis of the data, interpretations from the data for getting conclusions. So there are two types of statistics are there. One is your descriptive statistics, another is your inferential statistics. In our previous classes, we have learned the descriptive statistics, in which we have seen the central tendencies like your mean, median, mode. We have learned how to find all this, what the meaning of all this, and how we can find it out. We have also seen how to represent all these data and how we can find the variance, standard deviation, all that under the category of your descriptive statistics. Now, in this chapter, we will be learning about inferential statistics. So, what we do under inferential statistics is we draw conclusions from the population on the basis of sample, and then we generalize them to a larger population. Now, what population is, what sample is, how we are analyzing it, that all we will be learning under this video. What we are doing under inferential statistics is, first of all, we are talking about population. That means a group of big group. From this big group, we are taking out the sample. Then from the sample, whatsoever the sample we have taken, we are analyzing it. Analysis we are doing. And after doing the analysis, we are either doing the experiments on it, doing testing. We are doing the test. And then we are taking it out. Conclusion about the population means what we are doing is basically we, instead of taking the population, what population is, what sample is, all this we will be learning in this video. From the population, we are taking out the sample. Then we are analyzing the sample. We are doing experiments on it. We are doing testing on it. And from these tests, we are taking out some conclusion. Conclusion about what? Conclusion about the population. This all we will be learning under inferential statistics in this video. Now let's see what is population and what is sample. In our day-to-day life, we generally say population to be a group of people. But in statistics, it is not only the group of people, but it could be group of objects even. It could be group of events even. It could be group of experiments. It could be group of observation. Means whatsoever the conclusion we want to make, on which thing we have to make the conclusion, that whole group is your population. Like if I am want to say that what is the literacy rate of India, that means the people of India, the whole population is your population in this case. But if I want to say that what is the efficiency of any of the electronic items, say smart watches, then whatsoever the smart watches are coming out in, say, in 1 month, that is producing, that will be the group of population, that will be the population in that case. That means whatsoever the conclusion we have to make, on which thing we have to make the conclusion, on which object we have to make the conclusion, that whole thing is your population. Now, there are two types of populations are there. One is a finite population, another is your infinite population. As the name suggests, finite means that can be counted. So it is a countable group of objects, events and experiments. That means if the group of objects, group of events and group of experiments we can count, then it comes under the category of your finite population. Like example, we can say if we have to conduct an experiment on the students of a school, then the number of students in that particular school will be the population, because we can count it. That's why it will come under the category of finite population. Similarly, if we say population of any of the city, we have to conduct any of the experiment for the population of the city. Like we want to check whether they like any particular dish or not. So that particular population of that city will be the finite population, because we can count it. Infinite population, as the name suggests, the population which we cannot count. That means it is uncountable group of objects, events and experiments. Example could be number of cells in the human body. How many cells are there in the human body? We cannot count. That's why it will come under the category of your infinite population. If we have to count, if someone says that count how many stars are there in the Milky Way, so obviously we cannot count it. That's the reason it will come under the category of your infinite population. So population are of two types. One is your finite population, which we can count. Another is your infinite population, which we cannot count. The number of objects, individual objects, in your population is your population size. How many objects are there, how many events are there, or the experiments or the observation or the number of people are there. That number of individual objects is your population size, and it is generally denoted by capital N. Now what sample is? Sample is a smaller group of members of a population. From the whole population we are taking out some members. Smaller group of members we are taking it out, selected to represent the whole population, which will be representing the whole population. See, it is not easy to conduct the experiment on the whole population. Like if we want to say the literacy rate of the India, so it is very difficult for to count your population of the India. So if we are going to take, instead of the whole group, whole population, we are just taking out some members which will represent the whole population, then this is known as your sample. A well chosen sample will contain most of the information about the population. So it is very important to select the people. That means to choose the sample, it is very important how to choose the sample. Because see, if I am saying the literacy rate, if I am going to take people from the Kerala, so obviously literacy rate will be high. If I am going to take the population from some other city, from some other state, say Rajasthan or say Bhopal or say MP. So if we are going to take from some other states or cities, the literacy rate will be different. Or if we are going to take from Kerala or some literate states, then it will be something different. So it is very important to select the sample. From where we are taking out the sample, it is very important. So sample is basically a group of members, small group of members, which is going to represent the whole population. Instead of doing our experiments on the whole population, we are conducting our experiments on the sample only, because it becomes very easy to conduct experiments on the sample, which will represent the whole population. Right? So sample size is smaller than the population size, obviously, because from the population only we have taken out the sample. So obviously sample size will be smaller than your population size, and it is generally denoted by small n. That means what we are saying is, if this is your population, so from this whole population we are taking out some sample. This is your whole population. Because it is very difficult to conduct experiments on the whole population, so we are taking out some smaller group, that is known as your sample. So we are conducting our experiments on this sample, and whatsoever the conclusions we are taking out for this sample, we are assuming that it will be true for the population even. So that's the reason it is very important aspect to how to we are taking out the sample. That is even very important. So what we could do is, suppose this is your population, say so many, these are the various objects which is same. Now another object is your this, which is same. Another object is this, which is same. So how we can find out the sample, how we can select the sample? Over here we can see there are so many circles are there, number of circles are more. So if we will be selecting in our sample, even we will be selecting more circles. Then see, then the number of your triangles, number of triangles are 4 over here, and number of squares or rectangle is 3. So we are selecting, say, 2 your triangles, and we are selecting 1 your rectangle or the square. So if we are selecting like this, which is more, we are taking more, which is less, we are taking proportionately, we are taking the sample, then it will be a better selection of the sample. Now let's see the difference between the population and the sample. As just now we have said that population is collection of all the elements. Whatsoever the experiment we need to conduct, whatsoever we have to find out, we are considering all the events, all the experiments, all the population we are considering, then it is your collection of all the elements, it is your population. But in sample, from the population we are taking some group. That means subgroup of the members we are taking from the population in the case of sample. So sample, it is subgroup of members of the population. In the case of population, it focuses on the identification of the characteristics. Its main focus is to identification of the characteristics is the main focus. Rather, in case of sample, it makes inferences about the population. Whatsoever the experiments we are conducting on the sample, it is finding out the inferences, and inferences is for the population. So it is making inferences about the population. The population, a survey done on the entire population is accurate and more precise with no margin of error, because we have considered the whole population. So there is no chance of error Error will be there if we have done any calculation mistake. But because we have considered all the population, so otherwise there is no chances for any error. But there is a chances of error in the case of sample, because we have taken only few members from the population and we are conducting our experiments on that sample. So there could be error could be there. So a survey done using a sample of the population has a margin of error. But it again depends upon the sampling, how we have taken the sample. If precisely we have taken the sample, then there is less chances for error. Then the measurable characteristics of population is called parameter. Whatsoever the measurable characteristics are there, like mean is there, standard deviation are there. So all these, if we are calculating for population, then they are known as parameters. But the same characteristics, if we are calculating, we are measuring for your sample, in that case it is known as statistic. That means the same characteristics that can be measured, like your mean is there, standard deviation is there, variance is there. If we are calculating for the population, then this measurable characteristics will be known as parameter. But the same measurable characteristics, if we are calculating for the sample, then they will be known as statistic. The measurable characteristics of sample is called statistic. That is your mean, standard deviation. If we are calculating for sample, then it will be known as your statistic. This is the difference between your population and your sample. Now what sampling is, how we are taking out your sample from the population, what this method is, that is your sampling. So what sampling is basically, it is a technique of selecting a small group, that is subset of population. From the population we are selecting a subgroup. The technique by which we are selecting is known as your sampling. So it is a technique of selecting a small group, that is subset of population. Why we are selecting it? For estimating for the characteristics without having to investigate every individual. We are not investigating the whole population. We are not analyzing or investigating every individual. We are simply analyzing or investigating a small group, and the process, the technique by which we are taking out this group, we are selecting this group from the population, is known as your sampling. Now how we are doing it? First of all, we are identifying and defining the target. What is our target group? Like suppose we want to find the average height of a students of a school. Then this students of the school will be our target group. So first of all, we will identify and define the target. Then we will select sampling frame. What the framework will be selecting? That we will be selecting the sampling frame. Then which method for sampling we will be choosing? We have to choose the sampling method we will be choosing. Then we have to determine the sample size. That means how many members we will be selecting from the whole population. That size we have to determine. Once we have determined it, we have selected it, then we will be collecting required data. This is how sampling is done. That means technique by which we are selecting the small group from the population for estimating your characteristics without investigating every individual is your sampling. Now what all the methods of sampling are there, we will be learning. Now let's see various types of sampling. There are two types of sampling. One is your probability sampling, another is your non-probability sampling. Now let's see what probability sampling is. So probability sampling is the type of sampling in which selection of members from the population is random. That means whatsoever the population is there, randomly we are selecting the members for the sample. In this, each member of population has an equal chance of being selected. There is no biasness. Randomly we are selecting any of the member, and there is equal chance of every member for being selected. It is also known as your random sampling. Like we were doing in probability, we were selecting randomly, we were selecting if there is a bag in which there are so many balls are there, so randomly we are selecting the ball. Similarly over here, even we are randomly selecting the member for the sample. There is no biasness in this. Now the probability sampling is even of four types. There are four types of probability sampling. One is your simple random sampling, another is your systematic sampling, third is your stratified sampling, and fourth is your cluster sampling. That means two types of sampling were there. One was probability sampling, another was non-probability sampling. In this probability sampling, even there are four parts are there. One is your simple random sampling, second is your systematic sampling, third is a stratified sampling, and fourth is your cluster sampling. Now let's see what simple random sampling is. So in this type of sampling, every member of the population has an equal chance of being selected. Again, as already we had said that in probability sampling, there is no biasness is there. There is equal chance of every member of being selected. So it is even the case in this sampling, every member of the population has an equal chance of being selected, and it is the most common method of sampling. That means whatsoever the population is there, suppose I am saying that there is a class of say 50 students, and from this 50 students we have to select any 5 students for any of the competition. Now randomly we are picking any 5 students without any biasness, like there is no more chances of any of the student of being selected. When this type of sampling is done, then it is your simple random sampling. How we can represent it? Like suppose this is your say population. In this population there are so many members are there, multiple members are there. From this we need to select say any 2 members we have to select. So randomly we are picking 1 member and 2 member. So without any biasness we are simply selecting 2 members. Whichsoever we want to select, we can select. Such type of selection sampling is known as your simple random sampling. Now the second is systematic sampling. This is even the same type of sampling, but it is little bit systematic comparatively to the first one. So what happens in this? It is similar to your simple random sampling, but it is easier to conduct. It is much more easier than the first one to conduct. How it is easier? In this, what we are doing is, first of all, we are arranging all the members either alphabetically or numerically or increasing order or decreasing order. Anyhow, we are arranging all the members of the population. Then from this arrangement, we are choosing at regular interval of randomly selected members. So what we are doing is, suppose again, this is your population. This is the population. Now what we had done is, the same class we are talking about, we have arranged all the students according to their roll number. So this is the roll number 1, then 2, then 3. All these we have arranged in their, as per their roll numbers, we have arranged all the students of the class. Like this we have arranged. They are arranged in their, as per their roll numbers. So this is systematically they have arranged. Now from these members, suppose I am to select 5 members. So what I'll be doing is, first of all, first number I could take any. Suppose from the 5th roll number. From the 5th roll number, I'll be taking the students, and every 6th student I'll be taking. So suppose first, second, third, fourth, 5. First student will be your 5th student, and after 5th, every 6th student I'll be selecting. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So randomly I am selecting the student. So this type of method, it is known as your systematic sampling. So what we are doing is, it is almost similar to the simple random sampling, but it is easier to conduct. In this, members are first arranged either alphabetically or numerically or increasing or decreasing order. We can arrange all these as per their height also. Anyhow, we can arrange the students order, and then they are chosen at regular intervals of randomly selected members. So this is how we will be selecting. If this is the procedure of selection, then this is known as your systematic sampling. In both the cases, there is no biasness. Randomly we are selecting the students, and there is equal chance of every student for being selected. Now let's see what is a stratified sampling and what is cluster sampling. So stratified sampling, in this type of sampling, the population is first divided into subgroups. That means whatsoever the population is there, we are dividing it into subgroups called strata. These subgroups are known as strata based on the relevant characteristics. Like it could be, your subgroups could be made on the behalf of your gender, even on the basis of your age, income, profession, whatsoever we want to take, we can just divide it into subgroups. And the member from each subgroup are selected using simple random or systematic sampling. So what we had done is, first of all, we have made the subgroups, and then from the subgroups randomly by simple random method or systematic sampling, we can select the members for the sample. So what we had done over here is, suppose this is your whole population. This is the population over here. Suppose I am taking an example of a class only. We want to find the average height of all the students of a class. Now what we can do is, we can just make 2 groups, one of the boys and one of the girls. Suppose we have made the 2 groups. This group is for your girls. This is the group for the girls. And another group we have made. that is for boys. Another group even we have made, it is of your boys. We have taken 2 groups. So divided the whole population into subgroups. Now randomly from the group of your girls, from the group of the boys, we will be selecting members. So randomly we have selected, say, one of the member from here, this member we have selected. Randomly we have selected from here also. So randomly we will be selecting the members, and then whatsoever the procedure we have to follow, we will be following. If we have to find the mean, so we will be finding the mean of these sample, and accordingly we will interpret for the whole population. So this is your stratified sampling. Now it is your cluster sampling. What happens in cluster sampling? It divides the population into subgroups. Over here, so we were generally dividing into 2 groups like that only. Now in cluster, we are just dividing into so many subgroups. So we are dividing the population into subgroups, but each subgroup has similar characteristics of the whole population. For the whole population, every subgroup is having the similar characteristic, and this is helpful when population is dispersed. When your population is dispersed, like if we are talking about the whole school, we have to find the average height of the whole students of the whole school. In that case, what we could do is we can make subgroups of class 1, class 2, class 3, class 4, like that we can make the subgroups. And once we have made the subgroups, then we can select the your members. Randomly we can select the members like this. Suppose this is your whole population, and in this whole population we are having students of the whole school we are having. So what we have done is we have taken students of class 1, we have taken students of class 2, like this we have made the subgroups. Students of class 3, like this subgroups we have made, and then from these subgroups we will be selecting the members for your further processing. So like this members can be selected for the sample. So we had studied till now that there are 4 types of sampling in case of probability sampling. So these 4 are the methods by which unbiasedly, without any biasness, randomly we can select the members for the sample. After various types of probability sampling, now let's see what is non-probability sampling. So non-probability sampling, in this type of sampling, the selection of members from the population is non-random. As in the probability sampling, what we were doing is we were selecting the members randomly. But here, in the case of non-probability sampling, we are selecting the sample from the population non-random. The process is your non-random. That means each member has not equal chance of being selected. As we were saying in the probability sampling, that every member is having equal chance of being selected, but here in the case of non-probability sampling, each member has not equal chance of being selected. That means it is having your biased results. The results from the non-probability sampling will be biased. But this type of sampling, it is very easier and it is very cheaper to access. Because why it is easy? Because biasness is there. We are selecting the persons as per our convenience. That's the reason it is easy even, and it is cheaper even. Another is we cannot use it to make the valid statistical inferences from the population, because selection is not proper. Selection of the members from the population is not proper. That's the reason it is not giving valid results, valid conclusions we are not getting from these type of selections. Now again, there are 4 types of non-probability sampling is there. As in the case of probability sampling even, there were 4 types of samplings were there. Similarly, in the case of non-probability sampling even, there are 4 types of non-probability sampling. First is your convenience sampling. Second is your voluntary response sampling. Third is judgment sampling. And fourth is the snowball sampling. Now let's see all these types of samplings. First is convenience sampling. In this type, the members are selected with the most convenient for researcher. Whosoever is doing research, for him or his, whosoever is the most convenient, he is selecting the persons who are most convenient. Like if we are going to research that which school is best in the nearby vicinity, or we can say in the particular city. So instead of selecting the members randomly, what we are doing is we are approaching our friends, we are approaching our family members who are very easy to approach, who are nearby even. We are selecting those persons only. So that's the reason our result will be biased. It won't be a proper result, won't be there, because the selection are most convenient persons are there. We are selecting those persons only. So this is your convenience sampling. The second is your voluntary response sampling. It is similar to your convenience sampling. In this method, people who are themselves ready to conduct the survey collect the sample data. That simply means, suppose we have to collect data for the city only. If for the city we have to collect some data, we have announced that we want to collect data for the best school in the city. So whosoever want to do the survey, they themselves are approaching to us. They are approaching to us and they are doing the survey and they are collecting the data. So over here, what people are doing, they are taking the self initiative. People themselves are taking the self initiative for the survey. So these two are your one of the type of your non probability sampling. So what your convenience sampling, how we can do it? See, suppose this is your whole population. This is the person who is doing the research, and these are the ones who is very easy to approach, and it is the whole population. This all is the whole population from which survey is to be done. Now what researcher is doing? Researcher is approaching the ones who are most convenient for him to approach, like the family members, like the relatives, like the ones who live nearby only. To those people only he is researcher is approaching. So this type of your sampling is known as your convenience sampling. Now in your voluntary response sampling, suppose this is your population, this is your population. Over here we have represented all this. It could be your objects, it could be we have taken population. Now this is the researcher. Now what happening is, he or she has announced that we want to research on this topic. Now what people are doing, people themselves are approaching to the researcher that we are ready to research, we are going to survey. So the people themselves are taking self initiative. They themselves are approaching the researcher that we are ready to survey. This type of survey sampling is your voluntary response sampling. Now let's see what is judgment sampling and what is snowball sampling. Judgment sampling. It is based on the opinion of an expert. That means whosoever is doing the research, as per the knowledge of the researcher, as per the expertise of the researcher, he or she is selecting the persons. That means it is also known as your purposive sampling. Here what is happening is, researcher selects participants based on their own knowledge, judgment and expertise rather than random selection. That means random selection is not being done. Whosoever is doing the research, as per his knowledge, as per his expertise, as per his judgment, he is selecting the persons. This type of selection is known as your judgmental sampling. Example, we can say like selection procedure of your reality shows is an example of this type of method. Now see what is happening over here is, suppose this is your whole population. This is the population. Over here we have taken this as the population. Now this is the researcher. Now what he is doing, as per his knowledge, as per his expertise, he is selecting some persons. Randomly, not randomly, he is selecting the person as per his expertise, as per his knowledge. This type of sampling is known as your judgment sampling. Now the next is your snowball sampling. In this type of sampling, what is happening is, we are first selecting some persons. Some persons we have selected, then with the help of these selected persons, more persons are selected. That means we have selected some person, then these persons are again selecting some other persons, then those persons are again selecting the person. That means a proper chain is formed. That means this process is continuous to collect the sample, and it is same as your snowball increases in size as it rolls down. As we know, when the snowball is rolling down, its size keeps on increasing. Similarly, initially we have selected some persons. Now these persons are selecting some persons, and those persons are even selecting those some new persons. That simply means your process keeps on moving and your sample size keeps on increasing. This type of sampling is known as your snowball sampling. And example could be your chain marketing could be there. Like if we are going to see it, suppose this is your whole population is there. Over here, this is the first, initially this is a researcher selected say 2 persons. Now this person has even selected 2 persons. This person has even selected 2 persons. Now this has again selected 2 persons. Similarly, this chain will keep on moving. Your number of persons will keep on increasing. So this is known as your snowball sampling. From the initially less number of persons, your persons keeps on increasing. This type is known as your snowball sampling. Just now we have seen various types of sampling, that is probability sampling and non-probability sampling. Now let's see the types of samples. So there are two types of samples. One is your representative sample, another is your unrepresentative sample. Now let's see what is representative sample. So representative sample is a subset of population which accurately represents, reflects or matches the characteristics of the population. It has to be unbiased reflection of population. So what we are doing is basically from the population we are taking the subset. That means sample we are taking out from the population, and whatsoever the sample we are selecting, it is completely reflecting or representing your characteristics of the population. If this is the condition, then such type of samples are known as representative sample. Now what all are the characteristics of your representative sample? That selection should be your random. The selection of your sample means whatsoever the from the population we are taking out the sample, the selection of these samples should be your random. It should not be biased. And the sample size must be large enough. That means sample should be big enough. If your sample size will be small, that means if less number of events or experiments or people we are selecting, in that case your result won't be accurate. It won't be representing the whole characteristics of the population. And if the sample size will be more, then it will be more accurate. That means it will show more accurately the characteristics of the population. So how we can say it? Suppose this is your population, and from this population we have taken this sample out. This is the sample and this is the population. From this population, if this sample is completely representing the characteristics of population, in that case it is known as your representative type of sample. And if this sample is not representing, not reflecting the characteristics of the population, then this type of sample will be known as your non-representative type of sample. Now let's see what non-representative sample is. A non-representative sample is a subset of population that does not represent, reflect the characteristics of the population. It is biased in nature. So just now what we said is, that means from the population we have taken the subset. That means we have taken the sample from the population. Now if this sample is not representing, not reflecting the characteristics of the population, then such type of sample is known as your non-representative type of sample. Now how we can understand this? We're using an example. Suppose we want to know that what is the most commonly eaten food in India. Now suppose I am saying I went to the South India, and from there I have asked some people, or I have taken the sample from there and just asked the people. So people over there, most of the people said that dosa is the most commonly eaten food. Now if throughout the India I have selected some people from some from Rajasthan, some from MP, some from Uttar Pradesh, some from Punjab, some from South India, from all of the states I have selected some people and then asked. Then the result came that most commonly eaten food is your chapati, or the roti is the most commonly eaten food. So the first inference which I took from the South India was an example of your non-representative sample. Why? Because that was not showing the characteristics of the population, the whole population. It was focused to particular location only. So that was an example of your non-representative sample. And now when I have collected sample throughout the India, and then whatsoever the inference came out, that is representing your representative sample, because that is showing the characteristics of the population. Population over here is your population of India. That means that will be the representative sample, and the prior which we had taken from only from the South India, that was your non-representative sample. Now let's see what is unbiased sampling and what is biased sampling. Unbiased sampling. A sampling is called unbiased sampling if each element or member of the population has an equal chance of being chosen to be the part of the sample. That means if from the population we are selecting the sample and every member of the population is having equal chance of being chosen to be the part of the sample, then such type of sampling is known as your unbiased sampling. We have already learned that the probability sampling is an example of your unbiased sampling, because in the probability sampling, randomly we are selecting the people, selecting the members from the population to be the part of the sample, and every member of the population is having equal chance of being chosen to be the part of your sample. So such type of sampling is either known as your probability sampling, or it is even known as your unbiased sampling. Now the biased sampling, a sampling is called biased sampling if some elements or members of the population have higher or lower probability than others of being chosen to be part of the sample. That means every member of the population is not having the same chances of being chosen to be the part of the sample. Some members are having more chances and some members are having less chances. Some members are having more priority and some members are having less priority to be chosen as a member of your sample. So this process favors certain outcomes over others. That means some outcomes are there which are more favorable. That means they are having more chances of being selection, and some are having less chances to get selection to be the part of your sample. Non-probability sampling is your biased sampling, that we have already learned that in the non-probability sampling, biasness is there. Randomly we are not selecting the members to be the part of the sample. So such type of sampling is known as your biased sampling. So it must be clear what is unbiased sampling, what is your biased sampling. Now let's understand this with an example. Suppose I am having 1000 books. 1000 books I am having, and from these 1000 books I am to select any 100 books. So these 1000 books, say I am saying say 200 books are of maths, say 300 books are of English, say 400 books are of science, and 100 books are of SST. Suppose these 1000 books we are having, and from these 1000 books I need to select only 100 books. That means for sample, this is your population. From this population I am to select some sample, and in that sample I'll be taking 100 books. So in that sample, because say I love maths, I love doing maths, so what I'll do, I'll take most of the books of maths. Suppose from this out of 100 books I have taken 70 books of maths. Say I have taken 15 books of science. Say I have taken 10 books of SST, and I have taken 5 books of English. Out of 100, 70 books I have taken of maths because I love doing maths. 15 books I have taken of science, 10 of SST and 5 of English. Out of 100, this is the selection I have done. So obviously this is your example of your biased sampling, because I was biased for maths. I was having affection towards maths. That's the reason I have selected most of the books of maths only. So this is an example of your biased sampling. Instead of this, if I would have selected, say, because maximum books are of science, so suppose I would have selected science books 40, your English book I would have selected 30, maths book I would have selected 20, or your SST book I have selected 10. If this type of sampling I would have done, then this is an example of your unbiased sampling, because maximum books were of science, then it is of English, then it is of maths, and then it is of SST. So in our selection also, maximum books should be of science, then of English, then of maths, and then of SST. So if I would have selected like this, then it is an example of your unbiased sampling. And if I had selected like this is an example of your biased sampling. Hope it is clear that what is biased sampling and what is unbiased sampling. Now let's see what is parameter and what is statistic. Parameter is the measurable characteristics of a population. Whenever we are measuring the characteristics for population, then such measurable characteristics are known as your parameter. Like if we are measuring mean, variance and standard deviation, all these measurable characteristics, if we are measuring for population, in that case it will be known as parameter. And if we are calculating it for population, then it will be known as population mean, population variance and population standard deviation. Population mean is represented by mu, population variance is represented by sigma square, and population standard deviation is represented by sigma. Similarly, if measurable characteristics we are calculating for sample, then it is known as statistic. That means if measurable characteristics like mean, variance, standard deviation we are calculating for sample, then they will be known as sample mean, sample variance and sample standard deviation. And sample mean is represented by x bar, Sample variance is represented by S square and sample standard deviation is represented by S. That simply means whensoever measurable characteristics are measured for the whole population, then they will be termed as parameter, and when these measurable characteristics are measured for sample, then they will be termed as your statistic. Now what is the difference between these two? Parameter, as just now we had discussed, that it is the characteristics of population. That means measurable characteristics when we are calculating for population, then it is your parameter. And statistic is characteristic of a sample. Parameter is a numerical value that is taken from the entire population. That means we are calculating for the entire population. Mean will be calculating for the whole population. Variance will be calculating for the whole population. If it will be calculated for the whole population, then it will be your parameter. Statistic is a numerical value taken from a sample and calculated from the sample. That means whatsoever the sample we have taken from the population, for that sample only we are calculating the mean or the variance or the standard deviation or some other measurable characteristic. If we are calculating, then it is your statistic. Parameters are generally denoted by Greek alphabets. Just now we have seen that population mean is represented by mu. Your population variance is represented by sigma square. Population standard deviation is represented by sigma. So all these are denoted by your Greek alphabets, whereas statistic are denoted by your English alphabet. Like your sample mean is denoted by x bar. Your sample variance is denoted by s square. Sample standard deviation is denoted by s. So they are denoted by your English alphabets. Examples we can take, like if we have to find the average height of all the citizens of India. So here your population, whole population we are considering, whole citizens of India we are considering. So because it is for the population, that's why it is your parameter. Or we can say if we have to calculate average marks scored by all the students of a class, then it is an example of your parameter. Now, instead of this, instead of all the citizens of India, we have taken a sample. This is the population. From this population, we have taken out the sample, say, of 100 citizens. And if we are calculating the average height of these 100 citizens of India, which is sample of all this population, then it is your statistic. Similarly, instead of the whole students of the class, if we are calculating the average marks scored by 10 students of a class, then it will be your statistic. Hope it is clear that whenever we are calculating the measurable characteristics for the whole population, then it is your parameter. When we are calculating the same measurable characteristic for your sample, then it is your statistic. Now let's see what is sampling error. The difference between a population parameter and a sample statistic is known as sampling error. We have already learned that the measurable characteristic, if we are calculating for the whole population, then it is known as your parameter. And if from the population we have taken some sample and for that sample we are measuring the characteristic, then it is known as your statistic. Now suppose we are calculating the mean, and for the whole population we have calculated the mean, then it will known as your population mean. And from the population we have taken the sample and we are calculating the mean for that sample, then it will known as your sample mean. The difference between this sample mean and the population mean will be known as your sampling error. This sampling error could be positive also and it could be your negative also. And the estimated sampling error decreases as the sampling size grows. That means if the number of observations will increase in the sample, in that case your error will be decreasing. Why it is happening so? Because see, if the number of observation in the sample will increase, then means we are approaching towards the population. We are approaching towards the population, and that's the reason our error will decrease and we will be approaching towards your population mean. That means your sample mean will approach towards your population mean. So sampling error is denoted by your x bar minus mu, where x bar we know it is your sample mean and mu is your population mean. How to find your sample mean? We know that the formula for finding mean is sum of all the observation upon total number of observation. So x bar is your sigma of xi over n, where sigma of xi means whatsoever the observations are there in the sample. If we are going to add all that, that will give you a sigma of xi divided by n. N is your sample size. That means how many members are there in your sample. If we are going to divide these two, we will be getting sample mean. Similarly, population mean we can get by sigma of xi over n. Now what sigma of x over here? Whatsoever the population is there, if we will add all these observations together, then it will give us sigma of x, and capital N is your population size. So if we will be dividing these two, it will give us your population mean. So when your sample size will increase, then we will be approaching towards your population mean, and that's the reason your sampling error decreases when we are approaching, or we can say when the sample size is increasing. Now why there is error in the sampling? So there could be so many reasons for it. One of the reason could be your faulty selection of the sample. That means sample is not selected properly. Selection of the observations, whatsoever the sample we have selected, it is not selected properly. In that case, there could be error. Or the small size of the sample could even be one of the reason. See, if the number of observation we have selected, say suppose I am saying that there are 1 lakh people are there, and only we have taken 10 or 15 members as a sample. In that case, we won't be getting proper accuracy, we won't be getting in the finding your mean. So that's the reason if your size of the sample will be very small, in that case also there will be error in the sampling. So there could be so many reasons. These could be some of the reasons. Now let's see what is central limit theorem. Central limit theorem is even known as your CLT. So according to your central limit theorem, the sampling distribution of the sample mean approaches a normal distribution, that is your bell-shaped curve, as the sample size gets larger, no matter whatever be the shape of the population distribution. So whatsoever be the shape of the population distribution, suppose this is the shape of the population distribution, so it is not making any difference whatsoever be the shape of the population distribution. If your sample size is big, means if sample size is larger, in that case your distribution for the sample will be your normal distribution, or it will be your standard normal distribution if your sample size is large. So this could be your distribution for the population. It is not making any difference. Distribution for the sample will be your standard normal distribution if your sample size is large. What does large mean over here? That means it should be 30 or more than 30. That means for any type of population, sample taken around 30 in size. That means it should be 30 or more than 30. If the sample size is this much, then the distribution will be your normal distribution for the sample distribution. Now see, this is showing your distribution of the sampling will be your normal if n is large. That means number of persons, number of observation in the sample, if it is large, then the distribution will be your normal distribution of your sample. And if it is not this much, that means if it is not 30 or it is less than 30, then it won't be like this. It won't be your normal distribution. But if sample size is either 30 or more than 30, then the sample distribution will be your normal distribution. Whatsoever be the shape of the population is, it is not making any difference. This is your central limit theorem. Now a sample size of 30 or more is considered to be sufficient to hold CLT. As just now we said, then in the sample there should be at least 30 should be there. Sample size should be at least 30 or more than 30 for holding this statement that the sample distribution will be a normal distribution. It is the case when your sample size is either 30 or more than 30. And as the sample size becomes larger, the prediction of the characteristics of population becomes accurate. And as the sample size will keep on increasing, if we will increase the sample size more than that even, then whatsoever the characteristic we are calculating for the population, then it will be accurate. Because sample size we have taken large, so in that case, whatsoever the characteristic we are calculating, whether it is mean or variance or standard deviation, whatsoever the measurement characteristic we are calculating, it will be accurate for the population. Now let's understand one of the question based on your CLT. So as per your central limit theorem, when sample size increases, the mean of sample of data becomes close to mean of overall population. As just now we have discussed, when the sample size is increasing, then whatsoever the mean we are getting from the sample, it becomes close to the mean from the whole population. That simply means if the expected value from the sample, it is your E x bar, then it is almost equivalent to your mu, that is your population mean, when your sample size is increasing or sample size is more or it is large. In that case, your expected value or the mean from the sample will be equivalent to your population mean. And in that case, sample variance, that is your S square, will be equivalent to sigma square over n. Similarly, sample standard deviation S will be sigma over root of n. Over here we can see S square is sigma square over n. If we are going to take the square root of the whole, we will be getting S is equivalent to sigma over root of n. So these are the values for the sample if your sample size is more or it is large. Now let's see the question. A sampling distribution of the sample mean, that is x bar, is formed from a population with mean height mu is equivalent to 163. Over here mu is given to us as your 163 centimeter and standard deviation sigma is given to us as your 7 centimeter. What is the expected value and standard deviation of x bar? Expected value, that means E x bar is asked to us. Along with that, if sample size is your 49, n is given to us as 49. Along with this, your standard deviation is even asked. That means value of S is even asked to us. Now, just now we have said when your sample size is more, it is large. In that case, expected value E x bar is equivalent to your population mean, that is mu. Over here we can see the value of n is 49. That means sample size is more than 30. That simply means we can apply these formulas. So expected value will be your E x bar will be equivalent to your mu, that is your 163 centimeter. Now we have to find your value of S, that is standard deviation we have to find. So value of S, it will be, from here we can say that it is sigma over root of n. Sigma over here is your 7 and value of n is your 49. So root of 49. We know the root of 49 is your 7. So it will be your 1. So standard deviation, it will be your 1 and expected value, that is E x bar, will be your 163 centimeter and this will be your 1 centimeter. This is how we can calculate it. Hope it is clear to you. In this video, we'll be taking till now only, and in the next video, we'll be taking rest all the things, that is hypothesis test, t-test, that all we'll be learning in the next video of the same chapter. Till then, thank you.